This is a cool little subject. It kind of applies to sometimes to your everyday lives, but as developers, we have sometimes larger challenges to be solved that can be solved by breaking the problem down into smaller pieces. And this is a place where event-driven architectures can help. Little bit about me real quick. I've got over 20 years of experience in engineering scalable solutions and architectures. Currently working as a lead cloud solution designer at Jackson National Insurance. And I really enjoy software architecture, building scalable platforms, just really everything about software. And currently I'm learning to play guitar. I'm actually doing something outside of this. So for the agenda tonight, we're talking about event-driven architectures, but we need to start out and talk about what is an event. Then we'll talk about why do we want to use event-driven architectures. We'll delve into what the event-driven architecture pattern kind of looks like, and then I'll do a demo and do some other stuff afterwards with an opportunity for question and answers at the end. So what is an event? It's just something that happens. It's happens in the past. Typically, we talk about it in terms of a past tense verb. So an example of that would be, I attended the circus. That's actually my mom up there, who used to be in the Barnum and Bailey circus. So just if you attended the circus back in, I think that's circa 1963, you would have seen her hanging by her hair and juggling. And you would have been maybe assigned a ticket number or something like that if you were trying to record something about that event. Or you might be talking about like completing an order. So like a sales order, you'd be thinking about like the sales order number and the order amounts maybe. But it's usually something simple about it. It's not always the full picture of the entire thing. We're mostly interested in what makes that event unique. Something else about events that are kind of interesting is that we can replay them in time and talk about different outcomes. So as you get one order and two orders, you can sum the total of them and figure out both the number of orders that you got just by counting the number of events that occurred. And you could also look at the total amount of those orders if we use this as an example. You could also do something along this lines, like what was the greatest order number I'm at just by looking at this. So you could redetermine where you're at. So why event architectures? So I'm looking at a workflow here of using that orders as an example. Does anybody see any problems with this process? Anybody want to dare to say yes or no? Do you think this process would work like if you try to go place an order on a website? Why? So this is really about looking at this as a process as a whole. This process is something that would actually be a normal order processing. Usually a small business would start exactly right here. Very simple, do everything all together. When you place an order, you'd total up your items, you'd validate your inventory, you'd charge the credit card, and you just return them to an order screen that says, hey, you had a success. But what if we were to think about this a little bit differently? what would happen if all of a sudden the credit card processor that was at the end of that was broken and down? Chances are you would end up having this kind of problem of now I can't capture my orders, right? If you think about Amazon, it's really, really fast all the time. The reason for that is because they don't try to actually do everything at once. So if you go actually on their website, especially during like kind of like the holiday seasons, Black Friday, you put your order in, and there are sometimes some people get an email back that says your credit card's been declined an hour later, or we didn't have the inventory, sorry, it's going to be delivered in a month. We told you this date, but sorry, it's going to be that. That part of the process is being done in the background. It's happening because we placed an order, not while we're doing the order. And if you think of it from a business perspective, is what they're trying to do and is most important to the business is capture orders, right? Because what would you do if you got an error on the website and you were, say, buying a guitar and you got an error on the website and couldn't get it ordered? What would you do on their website, from their website? Go somewhere else. That's right. So, but it would be way harder to say, I've got an order captured. They got my order. Now you feel compelled to stay with them. They took my order, but there was a problem and they took care of it for me. And they waited till that problem, they could determine what that problem was and start giving me a resolution. And so thinking about that process that way is what event-driven architectures is really all about. It's thinking about the question, how can I do something later? So event-driven architecture pattern, okay? I did this presentation like a long time ago, and I had like 30 slides or so. And now after a whole bunch of experience in this area and talking about it a lot with people, I boiled this down into something I feel like is really simple. It's actually just the message-driven pattern, and I broke this down to the components that can be really meaningful and I can describe to you rather easily. The idea here is that you have a producer who produces events. The producer is typically a thing. It could be a system. It could be a supernova. So if you kind of want to think about this in terms of space, a supernova produces a huge explosion in light and energy. And millions of years later, we start to see it. If you want to break that pattern down here, the broker in that term is space itself. It's the distance between the event happening and us seeing it. We are consumers. We see it either with our eyes or instruments or something along those lines. If you think of it in terms of systems, it's a web server records a order being captured. An order has been placed, maybe basic verification, and that is the event. They stick it in to another system, and another system picks it up to look at it and consumes that event. Another analogy I might use in this case, and something that we do in real life, is a meeting. I have a problem and I need to talk to my manager. So I created a problem event. I had a problem right now, but I can't get it solved. So what do? I create a meeting. That is a cue for my manager to take a look at my problem. I don't put everything about that event. I only say that I had the problem. Then when we have the meeting, my manager consumes it and starts sucking off the information from me to help me with my problem. Any questions so far? Okay, cool. So kind of what I'd like to do now is kind of just jump into a demo and show you kind of the example of this shopping cart. Let me get this spun up here.
By the way, for the ones that are in online, please drop your questions on the chat and I'll make sure to pass it to Chris.
This is like totally in the way. There we go. Is my screen still sharing my Visual Studio?
I see your Visual Studio here,
okay.
but not there.
You see it? Oh, there. Okay, not there, but not there. Okay, let's fix that first. Let me switch back. Why not? Maybe here. It's not letting me out. There we go. All right, cool. We're all good now. All right. I've got a little application I put together here. This isn't meant to be like the perfect shopping cart or have all the features of a shopping cart. I just made it fill some values in here to pretend, you know, like we had a product, 5 products, and they have some values, and we have one that's 8675309. Some people might laugh at that. I'm almost too old for that, or too young for that, I should say. But it does have some of the basic features. And if I just click place order, I might have, okay, good. Immediately comes up and says paid. No problem, right? Well, I created a problem, and I'm going to demonstrate that here. So what I did as part of this architecture is I have just a basic web service that is my shopping cart. And I also created my quote unquote credit card processor that would be like your Visa. And today Visa is going to have a problem. So I'm going to put them into the problem mode. So the first problem I'm going to say is that we've gone from a normal workflow to they're slow. So they're not quite broken, but they're slow. And we're going to take a look at how that changes your experience. So I'm going to reset my cart here. And this time I'm going to place my order. Oh man, are we there yet? Oh, it took, 5, 6, 7 seconds. That experience, it's a simple page. We saw it work before and it went like that. And now our experience went right down the tubes. What are we starting to think? You know, it's not so great, right? And so if we do it again, you know, we can prove, oh, okay, let me try, you know, I'm going to do another order. And it's like, oh, right. And then someone's maybe clicking refresh. And now we've got all of back buttons and everybody's freaking out, and meanwhile it's been getting paid, right? And it's also sending all these extra requests to the credit card processor, and the credit card processor who's already slow is now getting slower and slower and slower. Okay, but that's all right, you know, like no big deal, you know, that happens during certain parts of the year. Maybe there's a system problem, but ultimately, where'd it go? Ultimately, what happens if we have a problem with our credit card processor? So I go and I place my order, and I kind of showed in a few, like a slide before, there was like this throw an error kind of idea, right? But it was in an email, but immediately I get this like, it's failed. We're not even going to take your order. sorry, can't process your order. Now, what kind of experience would that be? You know, like, so thinking maybe it failed really quickly. This could also be, I waited a really, really long time and then it failed. Either way, you've now, as a business, lost an opportunity, and as a customer, you've lost respect, right, for that company. So I thought I'd maybe just kind of share some of the basic spots of where this problem occurs first. So in this, I have some different sections of code, but this all boils down really to one little spot where it's dragging. And that is the payment service. So all of the magic happens in just a few lines of code. We're taking in an order here, trying to authorize the payment. If it's a success, we say it's paid, and if our credit card doesn't have enough money on it, it's declined. Okay, that would make a sense. Like if you have no money, we're not going to give you any product anyway. Otherwise, if there's a failure, just fail. So how could we change this process? Well, using the event-driven architectures, we can actually move this process to another system. I'll demonstrate here the kind of like what's going on first before demonstrating that. So remove one item, prove it's the same request. So you see here, I have an order and it's got an order amount of 2616. So that's our new order. It's in a new status right now. And then where's my step over button? I can't see it. Is there a way to get rid of this thing? Yeah.
I think if you
I hate to push another button, but so there was we're stepping into this code. And then finally, so it was slow. And then now all of a sudden I have an error and we're coming back and we catch that error and we're saying, okay, you're in the failed process. We're not going to process your order. So sorry. So like you might have an actual screen if you were this type of, you know, smaller business that just says, sorry, we weren't able to process your order, come back and try again later, right? Okay, so how can I change this process? We're gonna actually take the credit card processing and move it out completely and show what that experience could look like. The first thing I'm gonna do is I'm just gonna comment out this failed section here, or actually, let me think. So I kind of redid this like just the other night. I haven't gone through it like a billion times. So now I'm starting to feel the stress of doing a presentation on the fly. Okay, so I need to take this whole section out and I'm going to replace it with my new service. So I have down here, I'm using Azure Func. Oh, that's the payment service. Shopping cart, credit card. Yeah, that's it. Okay, so I created this service, and you see here the normal authorized payment portion of this process is occurring over here. So I'm going to take this, and this Azure function that's running in a completely separate process is going to do the work of authorizing the payment. And so you see it takes in this message. In a second, I'm going to show you how I'm going to pass it to it. So first things first, if I go to oh my gosh. It's like, so I have this paid service I actually created this queued payment service that kind of does this extra work. So we've taken this whole entire process and removed. So this is, I'm going to do this as a replacement to that other one. We've removed all of that stuff about try catch and worrying about anything happening. And we just said, first off, we're going to say that we're processing your order. So like if you came and looked at my order, it's not going to be new. It's not going to be quote unquote processing. So from a customer perspective, you're going, oh, you know, like not quite ready, not in the status, it's not shipping, you know, like you might go to some sites and they'll have like 4 bars across, maybe like back in the day of buying Dells, it was like order placed, order processed, building your machine, and then finally shipped, right? That's kind of what this is doing. We're shifting from a flat, straight process into an actual organized process that has state to it. The next thing we're going to do is just save that state, and then we're going to try and authorize that service by pushing the instead of pushing to the payment processor, we're going to push it into a queue. We're just going to push that message and say, we placed an order. Order has been placed. Any questions so far about what I'm talking about? What's going on?
Question by observation. So it looks like payment service.
That's correct. Exactly. So I'm going to be swapping out how we. So the question was about the interface that's up here at the top, this iPayment service. So if you look at the original implementation that we kind of stepped through, is that process went and called iPayment service. That interface is just a contract for the process. It's not how you implement it. So it's kind of like saying to a person, go buy a car. One person might go research cars and then pick a car and go buy it. And another person might just go online and order one from like a vending machine, right? Buying the car is the interface, and how you did it is the actual implementation or class about that. So in this case, our process was right in line with our existing process. In our new queued payment service, we're going to take this and we're just going to say place the order. Okay. So I'm going to do that by swapping out that interface. I was going to try and write it on the fly, but I'm not feeling it. So let's see, my shopping cart. I'm going to go to my startup. So this is using dependency injection to solve this problem. Dependency injection is just a mapping of these, what you want to do to how you want to do it. So I'm going to change that from payment service to queued payment service. And I'm going to spin this up again. And let me make sure that yeah, that's going to fail, I think. So I'm going to pull up what's called Microsoft Storage Emulator. Or a Storage Explorer. It's going to look at the emulated storage account that's on my computer. So like if you were running in the cloud on Microsoft, you would be using a storage account to do a lot of these things. If you were storing files or using the queued service or using their table storage for the solution, I'm using table storage and queues to actually solve this problem. And so where did Storage Explorer go? All right, cool. Let us know what you think. I think I'm doing a demo. So I'm going to go to the storage accounts here to my local attached. I'm going to check on the emulator, make sure it's actually running. It actually should be running because otherwise my website would be broken right now. Ooh, it's taking forever though. This is a bad experience from the demo guides. There we go. Whew. All right, so if I look at the tables, I have 2 tables here. I have a cart. Yeah, it's just running slow. I don't know if it's this presentation. You know, under the covers of this, yeah, I think it is SQL Server running underneath this. But you can see I have a bunch of orders from like doing lots of testing and stuff, all the different line items and like the various amounts and stuff. If we looked for the cart name at the top, one of these is going to be the ones that would be in there. And then the other part I have is the actual orders. So when you place the order, for the purposes of this demo, I don't actually care about shipping any products. So I didn't spend any time sharing them. I only captured the important information for proving the top portions of an order, which is basically like the order ID and the amount of money that you spent for credit card processing. And so if we look here, this last one at the bottom is the last order that I would have placed. And so, okay, so I made those changes there. And I made that change. I started everything back up. So I'm going to remove all but one item here. So you saw like immediately I went from, I'm already in this processing state. I've got a breakpoint here. So my customers already got their answer that their order was successful. So this is just no different than what Amazon would do is, hey, we got your order. For me, I just put processing, right? But the payment authorization is just now happening. I've actually got a breakpoint here. And from the perspective of that process, it's stuck. I could still go keep putting orders in and I'll actually do that real quick. I'll do another one. So I did one for $9.11. Oh, now the breakpoint. Of course, I didn't think that one through when I did that. Oh well. That's what you get for changing something during your demo. Okay, so I hit it again. We're hit here, but again, I got back into that other processing and it happened quick. You know, we didn't have that slow lag. Credit card processor hasn't even been touched yet. This order is sitting in a queue somewhere, waiting to be processed. But I'll let it go through. I think it's in normal mode now because I kind of restarted everything. So credit card processor is going pretty quick. It's only lagging by a few milliseconds. So if I actually refresh the screen now, it's paid. So this is just like you going on your website and it's like we're processing your order and you come back an hour later and now it says paid or it's shipping or whatever the new status is. Maybe a customer service person had to take care of this and, you know, it says, hey, you know, we're processing your request and we found a problem, you know, here's what we're doing to rectify it. Inventory is being checked, whatever those things are. We've pushed that off to a different point in time. But it even works not only when it's working really well. So this is, you know, a few milliseconds go by and everything's going well, but what happens around Black Friday? Let's take a look at that too. I want to go to Postman. So I'm going back to Postman here. I had it in the broken mode. We'll put it back into running slow. I'm going to set another breakpoint. So in my queued payment service. So the other part about this is I took this catch out, and the reason why I took it out of this process is I actually took this. This is one thing I kind of forgot to show you. So in this other process, you know, I kind of wired these things up. I actually took that same payment service and I just moved that whole thing to another place. That's all I really did. But in order to do that, I also had to take out that failed status. Why? Because now I have the opportunity, instead of just doing it once, if the credit card processor is having the problem, I still want to try and complete my customer's orders. And so rather than failing my customer's order, I'm going to try it again later, right? And that's another opportunity that you can't do while you're engaging the customer. So pushing this off, I now have the opportunity to try again without the customer seeing it or affecting the rest of my systems. With that said, I'm going to, let me think about this. I want to remove that off. That goes really quick. Trying to think where the slowness comes from in this thing. Let's see. I think it's over here. Sorry about this. I'm trying to, oh, I know where the slowness comes. So the slowness is in the credit card processor, and the failures happen in the credit card processor. So I can't show that as easily in terms of, but I can show it by sending a breakpoint here and here. So by putting a breakpoint here and here, I'm going to be able to show you, here's the point at which I call the credit card processor. And then here's how long it took to get here and get a different answer. One of those answers I can show as being an error in a minute, but we're going to go with, yeah, it's still slow, but my customer sees a good request. Okay. Any questions? All right, so we'll reset up our card again. I'll remove an item just to make it kind of different. I'll place my order. It's immediately processing. We've hit my breakpoint. So we're at that point. We're about to call the credit card company. Customer's already seen that their order has gone through. Calling the credit card company, calling the credit card company, calling the credit card company, calling the credit card company. Okay, just finished calling the credit card company. So 5-6 seconds went by. Customers still got their order. They're happy because they're like, oh, I'm gonna get my SpongeBob SquarePants jacket. Who knows? That was a really lame joke, by the way. And then it goes through, and then finally they come back, you know, minutes, hours, seconds later, they refresh the page, and now it's paid and going into those new statuses. So that's really the real huge benefit of building scalable systems around this stuff is, even as that thing, I can actually like stop the credit card processor altogether, so we can get to a failure state, put in a couple orders, we'll still see all of these orders processing normally. So I'll try that next. How are we doing on time, Sorella? I'm going to probably finish way before that then. All right, so Postman, hop back in here. We're going to call the credit card processor, and we hacked them. They're down. They're broken. So same breakpoints and everything. I'm going to reset my cart. And then we're going to also get to see some new features of what a queue is and how it works. So, yeah, right now I'm doing all C# Azure Functions, except for the front end is currently a .NET Core MVC app. You could put it in Azure Functions too, but just to keep it simple, I just did it as a ASP.NET Core app. And then I'm using the Azure Storage Emulator to do the database and queuing, just to keep it simple. It would be pretty easy, like 20-30 minutes to take this and actually put it out in the cloud, just by changing a couple connection strings and deploying these functions to an app service. So same thing, it's going to call the authorized payment. It's going to go really, really slow. Our status coming out of this is now is not declined and it is not paid. So my credit card processor is probably going to be a little bit angry and it's going to try again. And it's going to go slow. And it's going to fail again. All right, so while that's kind of going on, I'm going to break this out and we're going to go I forgot to let that run again. I should have gotten rid of a bunch of windows. All right, so man, still processing, still processing. All right, no big deal. I'm going to open up another window. All right, got a new credit or new cart. We'll do some different things. Additionally, place our order. That one's processing. Come over here. Still processing, still processing. Okay. That sucks. What's going on over here? It looks like it's been queuing up and looks like it may have failed and oh, it's still processing stuff, right? So we're still being processed. No big deal. Let's take a look at Azure Storage Explorer this time. Look at, see what's going on over here. So we're going to look at a new section here. It's called queues. So as I said, all that a queue really is if you think about like going to the movie theater, you get in line and you wait to buy tickets, right? That is the queue. And if you go to England, that's what they call it, queuing up. And so if you think about what kind of occurs there, the consumer of the line is like the person at the register going, next person, please, come on, right? That's the same thing. And so it works exactly the same way. If we take a look at what's in the queue, by now it might be nothing. Yeah, unfortunately it's nothing. There's probably one or two items over here in items poison, which there were two, so I was expecting that. So poison queue is, hey, I have a bunch of things I couldn't fix. I tried and I tried and I tried, and now I'm going to put them in this poison queue. But the thing isn't done yet. So if I take a look at our system here, customer is still waiting on their order. It's still processing. So from their perspective, something's going on, but they don't know or care what. They're just getting quick responses. My stuff hasn't gone through. And then if I go back to the credit card processor and I go, okay, credit card processor fixed their hacking, everything's back to normal. We're going to take this stuff out of the poison queue, this stuff I couldn't handle, and we're going to put it right back into the regular queue so we can process the credit cards again. So I'm going to move these messages from the people who I couldn't handle at the time, and I'm going to put them back into the regular queue. And so if we come back over here, we're going to see, boom, 2 messages immediately processed. Everything's back to normal. It happens so fast that you literally can't see this even if you refresh. So even Storage Explorer thought there was going to be 2 in there, and as soon as I clicked refresh, it's gone. And then the item poisons queue, same thing, it's empty now. So all of our credit card processing from our aspect has been handled. And now let's look at what the customer sees. So customer comes back, they're looking at their stuff. Oh, that one's paid. And I come back over here and that one's paid. There you go, bang. Process. So using event-driven systems not only allows us to scale by keeping all of that processing and all of the things that occur in this large system and splitting it up into multiple pieces, but it also provides us failure and scalability and resiliency to our processes. It allows us to keep our customers. It allows, you know, like that whole experience to just seem like it's amazing, even though the event of failure is occurring. Any questions of what I just did there?
Just to summarize, saying instead of doing it all in one month, something could go wrong, catastrophic, taking out those parts at 99 out of 100 times are perfectly fine, but once in a while fail, offloading that to what is like a thread.
Yep.
Events.
That's correct. And really, in terms of what connects all these pieces is only the smallest pieces of information. So taking your summary of, yeah, we're really offload. What is it that I can offload and put in a single sequence and offload and do it later? So you're asking yourself that question, can I do this later? What would be the effect? And in a terms of a business, when you're negotiating this, you have to negotiate, well, what if that fails? Well, that never happens. And it's like, yeah, but if it did, what would be the effect on our customer? What would be our opportunity cost in that case? You have to kind of explain that this little bit of complexity can not only just make the overall system faster, but it can also improve the customer experience. And that's ultimately like what you're trying to achieve when you're building systems for people, is those people are your customers. They don't want to wait. 1 second is like the limit of, is about the limit of a person's time span before they're like, smash, 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 smash. Why isn't it going faster? And that only makes the problem bigger. So yeah, that's a great way to sum it up. Absolutely. Any other questions?
They probably just got an event-driven architecture responsibly, because you could also introduce a whole lot of new problems to your system if you don't do it well.
So that's a great point. So there are some caveats to this. There's some trade-offs. You are adding some complexity to your system. You can't. You have to figure out ways of engaging that process in a different way to the customer. So now instead of like, how do I tell the customer that their credit card was declined in the event of a failure? I have to send them an email. Not always the greatest experience. Maybe if your business is a certain kind of business, maybe you're a Terminex or something like that, maybe you call your customer and say, hey, your credit card was declined. You know, we might put something in Salesforce and say, hey, here's the queue of people whose credit cards are declined. They're normally good customers, maybe their credit card, but you want to still continue to capture their business. So you do have to like build on extra processes onto these for those simple failures. If you're the small customer, maybe you can't afford or you're the small business that's doing this, maybe you can't afford that that extra process that would cost, and all of the other, you know, running multiple systems potentially. So that's a really great point. You do come with those trade-offs. Any?
I'll say one other comment too. Like, I'm going through it right now. It's like kind of fresh in my brain, but it's like depends on the technology that you're using too. So like, if different technologies solve problems different ways. So if you're using something like Kafka or RabbitMQ or something like that, like pub-sub model, message broker, stuff like that, it gets like a little bit hairy. The one thing that's killing me right now are retries, especially like so if somebody keeps hammering your site, keeps jamming up your queue, and you don't have item potency like configured correctly, like you're gonna DOS your own system. Because like, essentially you're just gonna keep trying to process the same thing over and over and over again, and it's gonna break your system.
So one of the things that was mentioned was item potency. So what that means is it's a mathematical term, but it just means that if I run a function, regardless of where I stop in the function, the playing it again will result in the same calculation. So if we think about like maybe algebra, x plus 1 is the simplest. If we stop before x plus 1 and we just pass in x and we stop, it's like, okay, well, the function didn't run, but if we run it again and we pass in 2, I'm still going to get 3 every single time. That becomes a little bit more complicated when you add state into the equation, whether it's like SQL servers or file systems, or as he mentioned, putting more and more things into the queue. But the idea is that you're having to put in your code safeguards to ensure that you end up at certain steps. So an example there would be getting something like a durable function or an orchestrator where you can set various points and then skip the things you've already done to ensure that you get there quickly or end up with that same result.
The poison too. Oftentimes I'll try something times and they say, I know it's not going to happen. Quick time, but now poison Q is a good last step.
Exactly. So that is an option. So good last step is the poison queue. Great point. Thank you. Where using the poison queue, you can say, okay, stop trying this at all. We'll come back to it. And maybe you have like monitors that are watching your poison queue for how many are in it. If there's one in there, somebody's getting a 3 o'clock in the morning email and going to try and fix it. Might be a resolution to that problem, right? So I wanted to just put together a quick slide of just like, so I showed you one possible solution out of these many that are here. I'm not even sure if I actually didn't list the one that I have here, which is storage account queues. I have storage account change events. That's actually a different thing. So the change events is basically like if you drop a file in a blob container, it will send out an event that says somebody put a file in there. And now you can trigger a function to do something. So something happened, I want to do something as a result. Every single one of these things are built around that. So an example would be like event grid, Cosmos DB change feed. So like Cosmos DB, you insert a record into Cosmos DB, event fires off, and maybe every time you get a new order, that's your way of identifying, hey, it came into database, that's my new order, now fire off this process to keep the thing moving. Some examples of some other brokers. So the broker is just the queue in all of these cases. What is going to tell the consumer that something's happening? The producer in these cases, though, is not always the same. So the producer might be, I put a file in something. I put a record in something. I put a message in something. I call a website. Any number of those is a possibility. It's just, how do I do something when something happens? I fire an event and I put it in a queue somewhere. The open source ones here, RabbitMQ, Kafka, that was mentioned earlier, they all do similar things, but they handle them in completely different ways. So they have different qualities about how they achieve what they do, and they're not exactly the same. So each one of these is not meant for every solution or problem. AWS also has like SQS, Amazon MQ, Amazon MSK, which I think is the Kafka like their scaled platform for Kafka. Azure Event Grid, Event Hub, Service Bus, they're all very similar in what they can do, but have very special qualities of which might be like at most once handling, which in some of these cases, things will fire multiple times just because multiple systems end up with that same message. And that's where that idempotent process is really, really important, is the way that these things handle stuff, sometimes it's at least once messaging. So it might happen 2, 3, 4, 7 times. So that's something to keep in mind. This is really just an introduction. You know, there's a lot more that goes about this, but it's just a way of thinking about problems and how you could use something like this as a solution. Yeah, go ahead.
I wasn't trying to scare people off or anything like that. Like, if you're using it for your personal projects, awesome. If you're using it for your company that's running millions of things all the time, read a book or something like this.
Right. Yep.
Don't do it blindly.
It's a way of sharing. Some other examples of that I've done in the past. In my previous presentation, I used something called SignalR to drive messages into the browser and make your experience real time. Having worked at Flight Docs with these guys before, we were using SignalR to drive some of our real-time platforms as well. So like, it's not just one technology. There's lots of protocols that you can use. You can do a polling model where you're like just checking to see if something changed as a model. You can use streaming technologies like WebSockets or anything like that to push things into the browser. It's really just about looking at what changed and pushing it somewhere and looking, how can I get that information to that consumer? Well, that's everything I got. If anybody has any other questions or comments, things you'd like to see. All right, thank you.
Thank you.
Oh, were there any in the chat?
No, but I'm going
Okay.
to share my screen now.
Go for it.
Are you muted? I'll mute myself and my camera. Okay, so we have a little script that for a raffle. I put everybody's names here. Wait, okay. That was done by Derek. And I have to say yes. Okay, almost there, guys, almost there. Talia? Awesome, thank you, congratulations. Okay, so let's talk after the meeting, so I can send you that. And for the ones that are new to the group, just so you guys know, we usually go and have pizza afterwards. You guys are welcome to, we finish a little early, so we can stay like another 15 minutes here. And after that, we're all gonna go to downtown we usually sit behind Downtown House of Pizza. On the open, there's not just pizza, but there's also like other restaurants around. There's like a little taco window thing there. And we really encourage you to come there because that's where we get a chance to talk. You can also talk to Chris and pick his brain more about everything in his career, especially for you guys that are on school right now. When I started on my career as a developer, I found Chris very inspiring on everything he knows. So he has plenty of good advices, so you should definitely talk to him. So thank you, everyone. We should be meeting. I don't have the event app on Meetup yet, but I should be putting it this week. We're still waiting on the confirmation of the speaker, but just remember that we always meet the second Thursday of the month right here. Okay, thank you, everyone. And if you, thank you. And if you guys wanna be on Slack, just come to me and I'll add you right now. Thank you. And feel free to do some networking right now. Okay, guys. Over there online. Thank you, everyone. for being here. We see you guys next time. Adam, so nice to see you.
I see you too, Zorella. Thanks so much.
Yeah, we see you soon and come visit us.
I'd love to. Absolutely.
Bye, guys.
Hey, Chris. Thanks a lot.
Oh, no worries.
I wish I could be out to
to
your
Thomas.
meet with you guys. I know I missed out a lot.
You
So.
said you're gonna have to
To
sit
Thomas,
at home and drink beer and eat
Yeah,
pizza.
maybe I'll do that. You know.
Have a good one. Thanks for coming.
Thomas,
Thanks a lot.
we are on Meetup. I'll send the link to Meetup right now. If you subscribe to the Meetup, you will have access to everything. Let me send you the here. Okay. Okay, so that's the link to our Meetup. That's where all the events are going to be. So just subscribe to that, and we hope to see you guys soon. I'm also on LinkedIn. I'm very active there. So just search me by my name, Zarela Graves, and I'm happy to send any information. Thank you, everyone. Good night. Thank you, guys. Thank you, Thomas, too. Thanks for joining. Bye-bye.